and some very basic discussions we did. So I'll take it forward from here. If you recall, we talked about that till Ariba we were dealing with the univariate situation where we had only one variable. As we have migrated from Rima to var, we are dealing with more than one variable together. And I also had a discussion that none of them in the var setup, none of them will be independent. Rather, all of them, all the variables will be dependent variable. So I tried to explain that it is not one way, rather it is two way. Normally what happens when y is dependent variable, x is cause and y is the effect. But when we talk about something like var model, in that case what is happening, the y may be the cause and its effect can be seen on the x1. So what is happening that both are, I mean, in one way, one is cause, other is effect. In other way, the other is the cause, and the first, I mean, the which was earlier the cause now become the effect. The effect on that can be seen. So that type of situation is known as systems of equation, and all the variables technically we call them endogenous variables. So independent variables are exogenous, and dependent variables are endogenous. So in var setup, we have got all the variables, whether they are 2, 3, 4 or more, all of them are endogenous variables and we call them systems of equation. And I discussed that the structure, broader structure of that, and I have showed that we have to take something known as lag values. The way we had a discussion on ARIMA modeling, where we have to fix a appropriate lag number. Here also in where we have to fix a appropriate lag number, where according to the lag number, we'll be having the lagged term of all the endogenous variable in each and every equation. As I explained here in last class, let's talk about first. First means the first dependent variable y1. So this can be y1t, can be explained with the help of lag variable of its own term and lag of other endogenous variable present in the system. And whatever is the lag structure, that lag structure will be followed in all the equation with all the endogenous variables. Same structure you are finding when we are talking about second equation, which is the equation of y2, second endogenous variable. And that can also be explained with the help of this structure, lag term of y1, lag term, one lag, because we have taken lag structure as one. Third variable also with one lag. And this becomes the equation. What is changing? Coefficients change, constant, coefficient attached to y1 t minus 1, y2 t minus 1, and y3 t minus 1. Same structure for the third endogenous variable. So number of equations will be as many endogenous variables are there in the system, and every variable will have as many lags as we have decided for each and every endogenous variable. One point to be noted here is that in no equation you are finding contemporaneous endogenous variable on the right side. What I mean by this, if I write it this way, if I just write it in one case, y1t is equal to alpha 0 plus beta 1 y 1t minus 1. If I'm still sticking to the one lag issue, this is y2t minus 1 plus beta 3 y3t minus 1 plus error term, obviously. So what is here? No term is in t, whereas this term is in t. So this is of same time period, there is no variable. Every time you are finding lagged term of all the endogenous variable, whether this is 1 or 2 or 3, in every case, you won't find contemporaneous term in the on the right hand side. On the right hand side, only lagged terms are there for each and every endogenous variable present in the system. The same thing will be applied for all the three or as many as the endogenous variables are. Accordingly, things are done. Is it okay? Is it okay?
Yes, sir.
So we'll move forward. We'll have some issues to take care in VAR setup. I'll fix it and I would like to finish them. We will see how it can be estimated. After estimation, we'll obviously, when I say estimated lag structure, we'll fix the lag structure, number of lags. Then we'll go for forecast, how to calculate the forecast. Then we are something known as impulse response variance decomposition. These are nothing but trying to understand how y1 impacts y2, y3, and y2 impacts y1, y3. When there is some change here, so it is the learning, the understanding will obviously be developed from the systems of VAR estimation, but we'll be using a new term which we call impulse response and variance decomposition. So that will give more accurate idea if I want to study the impact of one on the other. I'll give you some idea about volatility spillover also when I come to that point. And that's it. We'll cover this much. I think, let me check if I'm missing out anything that I thought I would be sharing with you. That's it. And if we finish that in time, we'll move to next topic, which is co-integration. So that is agenda for today. We'll go to e-views.
So we won't be having the test today.
Did I commit some test?
Yeah, in the last class you told us about the test. You were going to take it on 5th of November, but then you moved it up in the next class.
Okay. So I have to check. As such, I have not scheduled any test today. So no test as such. I think that fine. I don't have. Mentioned the test sequence. I don't think so that I have planned that way.
Okay.
Let VAR get over, then we'll have it. To the extent I remember vaguely, I have planned one test after VAR.
Okay.
So I'll inform. I'll inform to your CRs, and through CRs you will get to know. Right?
Sure. Thank you, sir.
So we'll talk about something. We are talking about VAR, so I'll open one data set where we have more than one variable, one time series. So this data set I picked up from my earlier research work. As you're finding, that data is from 2000 again weekly up to 2011. Quite old data, but that's not important. Data is old and new. So we'll be making use of this data set. I have taken 3-4 out of, there are many indices. Some study was there on comparing developed versus developing economies using co-integration and all. And co-integration is somehow or the other related to VAR. We'll discuss that as well. So something already have. I'll just use that. Same thing, nothing big. I've just copy pasted. I've ensured that there's no missing values and all. That's why I'm preferring to use it. So I've taken these 4. I could have taken others also. That's not a big deal. Same thing, same prices in levels. No first difference. I can show you also. So same thing, what we have just there. No change as such, same. And I've just taken BSc, Singapore, Taiwan, China, that's it. One important thing is, as we go for estimating VAR model, and if we are clear that we are interested in estimating VAR model for forecasting. So if you remember my discussion on ARIMA, if we have got, let's say, here for argument's sake, we have 2703 data points. Observations are 2703. And I want to go for forecasting. So right now I've taken 2710. It's slightly higher. I usually take 3 more, but I've taken the worksheet like that. So there's nothing big problem as such. So if you are clear that you would like to use the data set for forecasting, then before you enter the or copy the data set on eViews, you decide that for the period for which you would like to do the forecasting, that many extra periods you should always take when you decide that how many observations you want to have in a particular worksheet. Keeping that in mind, 2703 is the number of data points, and 6 more, 7, 4, 5, 6, 7, 8, 9, 7 more, so it becomes 2710. As you can see here, there are 2703 data points, and these 7 data points are vacant. And I have intentionally taken them so that I can use these vacant spaces for forecasting. One of the important purposes of using VAR modeling is to forecast. In ARIMA, we were restricting our discussion on only univariate. But as we move from ARIMA to VAR, we are talking about from univariate to multivariate. Bivariate is obviously bivariate is obviously included, but practically multivariate. So we are talking about multivariate model. So we are migrating, we are increasing the intensity, we are learning more things. So it's not that one particular time series is having its own story to tell if we want to forecast. Rather, we are talking that let's have, if I want to talk about, or let's say I want to forecast, then I'll have not only Y1, I would say, but I would be having impact of other possible variables. So that is the idea of using VAR model, that we are not restricting to one particular time series, rather we are going to add the impact of other time series on a particular time series. One thing let me discuss here. When we want to understand impact of others, then obviously we have got something known as multiple regression, as we are talking about y1t is equal to alpha 0 plus, I would like to use here x, like beta 0 x1, beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus u. And obviously I can put t here when I'm talking about time series. So this is multiple regression. And what happened when we are talking about impact of other series on a particular time series. So this is one example. Simple multiple regression. But then we are having something known as VAR. ARIMA is always there. Then we are having VAR, in which we are talking about systems of equations, where we are having obviously more than one variable, but all of them are endogenous. That is the idea. So this is a second way by which we can study the impact on one variable of other variable. If you look at in this example, I can say I'm talking about impact of on y1 of y2, y3 and y4. So this setup is known as VAR. This was the setup which we call multiple regression. Then we are having something known as co-integration. will be most probably starting today or next class. So in co-integration, what happened? We try to find out the long-term association. So when we talk about long-term association, so I have to differentiate VAR with co-integration. VAR is basically meant for short-term. But when I say co-integration, I'm talking about long-term. So there's a difference. Again, we have something known as vector error correction model, which is again part and parcel of co-integration. So that helps to understand long-term relationship. So here what I am saying, impact on y of other variable y2, y3, y4. But here the purpose is not short-term but long-term. So there's a difference. Same setup. If it is short-term, then we are talking about var. And when we are talking about long-term, then we are talking about co-integration, or to be more precise, vector error correction model. We'll be discussing about them. So if I say that when I'm interested in studying the variables impact on one variable of other variables, then we have a setup known as multiple regression. Then we are talking about another setup var, and then we are talking about one more setup which is known as co-integration. Let me talk about volatility spillover. I'll be visiting about them, I'll be talking about them, but just because this is the right context, because we are studying one impact of other variable on a particular variable, so it makes sense to study the volatility spillover at least to start approach the idea. What happened? Suppose I have got sigma 1, if I say square, so I'm talking about volatility of y1 measured with the help of sigma 1 square, which is variance of y1. Similarly for y2 I have got this. So if I have got 4 variables, then here what do we study? That up to what extent variance of y1 is getting impacted by variance of other. So here what we try to understand, how volatility of one variable is having the spillover effect. Means if there is some change here, how it is going to impact here. If there is some change here, how it is going to impact here. So right now the basic idea is how the volatility is getting impacted. So right now we are limited only whatever the variable is. Usually it is return, prices, and when we from prices we calculate return. And normally what happen, prices are, if you remember my discussion, prices are not I0, they are not stationary, rather they are I1. So when we are saying they are I1, so usually what happen, the return series are I1, prices are not. So that's why quite often you will find that we are talking about return series, and that is the logic for saying that return series. So volatility will be talking about a risk, impact of risk present in some other market, how it is impacting the risk in some other market. That we'll be studying in the volatility spillover effect. And right now, when we are talking about why, usually we are talking about return or change. So change become I0. When we have change, you will find that change are stationary, but prices are, or absolute values are not stationary. So just because we have to either convert that into first difference or we calculate the return, usually you will find that when we are calculating the return or rate, it becomes stationary, and that can be modeled. So that's why usually VAR, multiple regression, if we talk about the financial time series, you will find that those are usually return time series. So that was rough idea. I gave you 4 things when I talked about impact on one of others. When I say others, not limited to bivariate, rather multivariate. So multiple regression we have studied in detail. What we are doing, we'll be completing co-integration and volatility spillover effect. Practically, this is the sequence in which we'll be finishing the remaining portion of the course. So I'll come back to the eViews and just showing you that we have got 4 time series. So here, if I have to run the var, so I'll select them, go for right click, and I'll open, and you are finding something known as var. So it is by default set. We can open, and here we have got the default dialog box that comes. If you look at that endogenous variables, it is considering that all the variables are endogenous. So all the variables what we have selected, they are coming: BSE, China, Singapore, and Taiwan. And we are assuming that there is a constant term. If you have seen the structure of var when we were writing the equation here, let's say this is the constant term. So constant term is still there. So this is the model. If you look at what is the model BSE, having, if you have paid attention, by default setting was 2 lakh, 1 and 2 lakhs. So as you are finding that BSE of 2 lakh, China of 2 lakh, Singapore 2 lakh, and Taiwan 2 lakh, same structure what we discussed here is coming out here. Right now it was 1 lakh, but here we have 2 lakhs because we have taken 2 lakh. We could have gone for 1 lakh also. You're finding 1 lakh. Same structure what we have done. We have taken 3. Here we are talking about 3. I have taken here 4, so there are 4 there. So in estimation, I'll repeat what I have done. Whatever variables, let's say I would like to go for 3, leave Taiwan. So these are one more thing. BSE, if I open these are time series, I'll go for checking the one condition. I just missed the discussion. When we say var, so one thing that all the time series should be I1. Unless until all the time series are I1, var can't be run. So this is the precondition of running the var model. So nothing comes free. We want to have the var, then you have to have the situation that time series is of the integration of order 1, means in first difference it should be stationary, but level it should not be. Clear cut? This is first thing. And second thing, when you are estimating the var, estimated levels, never go for estimating the time series when it is stationary, as we have done in ARIMA. ARIMA was a different because we wanted ARMA to be ARIMA, means integrated of order. So we have to have the stationary time series. That's why we artificially converted the time series by taking some difference and then putting the ARMA model, so that we have got a model which is having the stationary time series. But that's not the case in case of var. In var, when we are going to model it, we'll be modeling it in levels. So these 2 important things. Coming back to estimation part. So I'll complete the formality of finding the stationarity thing in levels. All are automatically default setup. Probability, if you remember, we have null in the case of stationarity, that the time series is not stationary. And alternate is yes, stationary, and we look forward to that time series should be stationary. This is not stationary. So if you look at the p-value is more than 0.05, null cannot be rejected, so we have to accept that the time series is not stationary. It is for those who would have forward. So we'll check this in first difference. First difference. I'm not disturbing the default setup here. And as we are taking the first difference, what we are finding that null of no stationarity is rejected, and alternate of yes, stationarity is there is accepted. So we'll say that the BSE time series is following the condition of I1. I'll check with the other time series also. Let's say China. So unit root standard levels. Again, we are finding not stationary. But as we move to first difference null is of no stationarity is rejected, means it is also I1. and I can check for Singapore. N level, it is having p-value which is more than 0.05. And first difference, it is having none of not stationarity is rejected. So we can say the data set which I have is following the condition of that all the time series which are there in the VAR system are I1. They are not stationary at levels, and they are not stationary at I2 also. So typically the condition is very well clearly defined. It should be I1 precisely at first difference. Time series should be stationary, then only VAR model can be run. Back. So what we were doing, we were running this. So all the default setup, and this is the model. But here, if you remember, we have discussed that we have to talk about the appropriate lag length. The way we have talked in the case of ARIMA, here also we have to talk in the same language. So to determine the appropriate lag length, we have got something. After running the VAR model, go to view, lag structure, and you will find lag length criteria. If you remember my discussion in ARIMA, we had talked about AIC, SIC, ACAC information criteria, Schwarz information criteria, and we prefer ACAC information AIC. Here we are going to have, let's say for argument's sake, you take 10 lags and look at AIC, and what you're finding, it is automatically showing you by the asterisk sign, which is the lowest. This 33.39232 is supposed to be the lowest. You can just quickly have a glance. You can confirm. If we go for SIC, then what we are finding that this first lag it is showing as the appropriate lag length, but we'll go by AIC. So now, whatever model we have estimated of VAR, we'll be correcting that with the help of appropriate lag length, which we are deciding with the help of AIC, ACAC information criteria. I mean, it is something like error, where the error is least. And what we are finding at the 9th lag using AIC design criteria, the errors are coming least. So we would like to run that. And here we go. So as such, nothing to interpret at this level. That's not, going to give you anything meaningful. Purpose is estimation, the forecast. So we'll go for forecast. And name, I can give a new name, forecast can be given. And here what you can do, you can go for 2703 was the number up to which we had the data. So we'll start with 2704 and we'll deselect this. I'm going for dynamic forecast. If you remember my discussion, dynamic when forecast value is also used for the future forecast. And that is just because we are interested in getting the forecast value for 7. So it makes sense to use this dynamic. If I use static, then only one time period forecast is possible. Beyond that, I won't be able to get. So it makes sense to go for dynamic forecast. These I can deselect. I don't want these output. So name suffix will have all the 3 time series which I have taken to run the VAR, BSC, China, Singapore. Let me put it just FR forecast will be there. So that suffix will be added in the name. I can see UBSC. So what you're finding here is the forecast value of all these 3 are there. I'll show you what it has given you. As you are finding, these are the forecast values. These are the forecast values which are there. Just a minute, something. Let me correct it. Yes. So if I show you, it will show you only the forecast values. So this is forecast values, and these values are the 7 period forecast values. Same can be done for others. You can have a look for China, Singapore. If I open them as group, you'll find that. So these are the forecast values as you're finding it here for China forecast and Singapore forecast values are there. So I've just intentionally removed so that clarity is there. So this is the method by which you can go for calculating the forecast values of the consent time series. Just because we have got 3 time series for which we are making the VAR model, so it is automatically giving you the forecast values of all the series taken. Anyone has got any questions so far? Sorry. Yes.
Sir, I had a question.
Please go ahead.
Sir, so while we were taking the lag length, sir, can we take a value greater than 10 also, right?
Yeah, we can take, but there is again a rule of parsimony, which suggests that we should take shorter models. So keeping that thing in mind, it is advisable that we should go for not very high level of lag lengths, but you can take, technically you can take.
Okay, sir. Thank you.
Anyone else? Yeah, anyone else? No one else has got any question? So this was the discussion on using VAR for forecasting. Let me remove this. So we are deleting VAR model as well. So we'll talk about something known as impulse response and variance decomposition. And that's something which is important discussion to understand, as I was talking about, how the other variables are impacting one particular variable. As I've given you a plethora of possible options. I mean, the way I said that volatility spillover, these will be studying with the help of Garch model. So we have got again univariate, bivariate, multivariate charge, co-integration, VAR is what we are talking about. But the main job is that we are trying to understand how one particular variable is getting impacted by the other variables. So if I say y1, how it is getting impacted by other variables, y2, y3, y4 in the given setup. That is what we are trying to understand. So in this process, as I have said, VAR is a short-term model, means it tries to study the short-term impact of these variables on another variable. Y1 is only representative. I could have replaced y1 by y2 and y1 could have been here. So that is what we are doing. So when we try to understand the impact of other variables on a particular variable, two instruments are very handy: impulse response and variance decomposition. They serve different purposes. I'll show you the diagram and data, and then accordingly I'll do it. I believe most of you are off somehow. It was a tiring day. Yes. It was tiring day. No. Yes.
Yes, a bit.
A bit. Tanay has spoken. What about others? It seems most of you are lost. Where are the other people? Only a few are responding. What about other people? Harshdeep Singh, where is he? Manisha Thakur. Is anyone there?
Yes, sir, we are here.
I said Manisha Thakur, Sneha, Sikaria, Jadhav, Saniket, Vikas Jadhav. Are they there?
Yes, sir, I'm yours.
Sir, I am here.
Good, good, great, great. Means I can, I get a feel that people are there. Good. So we'll be talking about impulse response. I'll show you how to estimate it, and then we will go ahead. So we'll again estimate. We'll use these three only. Open as var, and we have understood that 9 was the appropriate lag length. We'll stick to it, and we have got the model. So we have used this model for forecasting. We have seen how forecast estimates can be done. There will be plenty of occasions where you have got many time series and you would want to know what is the forecast of a particular time series, keeping other time series also in mind. So in a collective setup, you would like to know the forecast values, and as well as in the individual setup, when we talk about ARIMA modeling, you can go for forecasting. So that is very handy use of ARIMA or VAR model. So right now, what we are going to discuss impulse response function. So we'll be trying to understand up to what extent one variable is impacting or other variables impacting a particular variable. So as you are finding impulse response and various decomposition, we'll study them one by one. Let's go for impulse response. And one thing is clear, we are studying BSE, China and Singapore. Leading indices of all these three countries are there. And VAR, the model per se, uses only the values in level. So we have taken only prices. That was the basic structure with which we have gone. So the forecast values are also in levels. So that is good thing about the VAR model. If you remember ARIMA, we have to do the changing of or ensuring that time series is a stationary. Then we take first difference. If it is not at stationary at level, which is usually the case, then we have to convert that back to get to know the actual values. So that problem is not there when we talk about forecasting using VAR setup. So right now our focus is on impulse response. If I click this, so there are different options. I'll go for graph, which is I can go for table, but I'll suggest that for impulse response you can go for multiple graphs. Here what you can see, I'll show you, and period also you can change. Suppose you are not interested in for 5-10 years, go for 5 years. Means for 5 years you would like to see the impact. Or practically it is not the years but periods of 5 weeks. So 10 weeks makes sense. 10 weeks hardly 3 months. So we have got the weekly data. Let me remind you, we have got the weekly data. So 10 weeks, less than 3 months. I'm not disturbing anything. As I click, I've got something like that. I don't know whether it is visible. The graphs are visible.
Yes, sir.
Get a little more
Yes.
meaningful. Let me try if it can be done. Yeah. So impact of PSC, I think we'll have, yeah. But again, only the, let's all be together. So look at here first. What these three diagrams are showing you, that a response of BSC to BSC, and response of BSC to China, and response of BSC to Singapore. We need to understand that when we are saying response of one on other, then here an impulse response function logic is that as we have this equation in VAR, let me show you this equation. And in this equation, what is happening? This is one of the equations. If we have got 3, so obviously we'll have 1, 2, and 3. So suppose we are talking about 1. So in this, one standard deviation of we call it in the language of VAR, we call it innovation or shock. So we are giving a change, a shock of one standard deviation in this. And then we are trying to understand that if one standard deviation shock is provided to a particular variable, a particular time series, how it is impacting the itself and others. Because when we are saying that systems of equations, so we are not only y1, but we have y2 and y3. In our example, 3 are there. So in bringing change 1, we'll understand how it is impacting all 3. Similarly, we'll bring change in y2's shock, and then we'll see if I put it in more structured way. If I have got y1, y2, y3, so obviously I have got corresponding u1, u2, u3. So here if I bring change, one standard deviation, then its impact on y1, y2 and y3 is something what we are studying. So when we say then here one standard deviation change are there, how it is impacting all these three, that is what we are trying to understand. So impact of y2, y3 remains same. That's why you are getting some symmetrical output in terms of graphs. But logic is when we say the impact of BSC on BSC, then that is interpretation that there is one standard deviation shock is given to BSC, and then it is seen that how much it is impacting over the period of time on y1, y2, and y3. So this is short term. Any news come in the market, any type of problem comes in the market. So there is some shock given to the market. Then how the impact, the shock coming to one market is going to impact the market itself, how much resilient the market is, and how it is impacting the other markets which are there in the system. Right now we are talking about system of 3 time series. So that is the rough idea of when I say impulse response. So I'm free to have any clarification if you want to ask. So no one? So impulse response is okay. I'll show you here. So as I said, this setup and impact of y1 on y1 itself, on y2 and y3. This is what we are finding. This is a scale where response is shown in terms of price, and what it shows that the response is very high. Response of one standard deviation shock to BSC is giving maximum impact to as compared to these two. As you are finding, these are all are scaled in a similar way. So if you look at here, we'll come to impact of shock to BSC on China and impact of shock to BSC to Singapore. But right now what we are finding that the impact of shock to BSC is maximum in case of BSC, which is pretty obvious. And here what we are finding that we look at the blue line, that makes sense. It should be within the red line so that it is within the the range which is possible of changes. So that goes parallel to the main impact. And so these are possibilities, possibilities. So range is provided, but common value is also given. As you are finding, it hovers. The impact of shock to BSC on China, though data is old, but you are finding it is negligible. Rather, it is hovering at 0. And look at the impact of shock to BSC on Singapore stock market. What you are finding, though it is not very high, but not that 0 also. You are finding it is very small change, but yeah, changes there. At least it is more than the impact of shock to BSC to China, impact on China due to shock to BSC. So same type of interpretation can be done here, but you are finding that if there is a shock to one standard deviation shock given to China, then how it is going to impact BSC again? It is showing that negative impact, as you are finding it is below 0. Here in case of China again, but impact in China is quite less as compared to the impact of one standard deviation shock to BSC. It is much higher. And in Singapore, though it is not as strong as in the case of India, but yeah, This is good enough. Similarly, the same interpretation can be done for all the other time series. So this was one of the tools to understand the impact of one time series on the other time series. So this is impulse response. We are studying VAR. Let's talk about this was impact on price, and this talks about variance decomposition. It talks about the change in one particular market, how the volatility of that market is getting impacted by itself and by the other market. So how much impact in one market is going to be there over the period of time because of that? I mean, how the volatility in a particular market is dependent on the other markets, that too over the period of time. My statement will make more sense once I show you the data. So I'm going for variance decomposition. Yeah.
Sir, in this chart which you made for uh, this one standard deviation,
Impulse response.
yeah, impulse response. So, sir, in this period, like, what does it mean? Like, the shock of one standard deviation in first week across 10 weeks, like across 10
No, it means
periods.
that today at zero, when we are talking about, we have given a shock of one standard deviation. Shock means the impact on error term, so that we call innovation or shock. So what happened? Whatever is the error is uncertain. So obviously it will be having some standard deviation. So one standard deviation plus minus shock is given, and then the impact of this shock on the market itself, of which it is the shock. I mean, this U1 is of the, let's say, BSE. So BSE's error term has been, changed. So how it is going to impact the BSE over the period of time? Over the period, this is the period. And you remember we have taken 10 weeks.
Yes, yes. So, over the period,
Over the
how
period of time, what you are finding, you are looking at the initially the impact is very high, gradually it goes down, and this is the real data, a real interpretation.
okay, sir, got it.
Same way we can explain all the other. So similarly, we are talking about variance decomposition. As I'm saying that the impulse response is more towards prices, and variance decomposition is more towards impact on variability of the prices. So impulse response price, variance decomposition, it gives you percentage-wise breakup of the impact on variance due to its own series and due to other time series. We have got three, let's say in our example, Y1, Y2, Y3, India, China, and Singapore. So it will show that if there is some change in India, how the variability in India is changing over the period of time due to itself and due to others. So how much other markets are impactful in explaining the variability in Indian market, that is being studied with the help of variance decomposition. Let me show you the data so that makes more sense what exactly I'm saying. When I go for variance decomposition, still I'm sticking to 10. Let's all default setting, but instead of graph, right now it is advisable to go for table because we'll be talking about percentages. So percentages are clear cut, well defined. So 100% variation is broken down into parts. So that would be good numbers to see. And here we have got the result. Look at variance decomposition of BSE. So it gives you, if there is some change in BSE, then variability of BSE over the period of time, how it is changing, how the impact of change in BSE, impact on variability of BSE is getting impacted by itself over the period of time, and how other markets are also impacting the variability of BSE, just because this is BSE's variance decomposition. Similarly, here we have got variance decomposition of China. So if there is some change in China or something happens in China, how that variability in Chinese market is there over the period of time because itself and because of the other markets. If other markets are influencing the particular market, then the over the period of time you'll find that changes are visible. Same thing for the third market, for the Singapore. So whichever market, suppose we are interested in looking at the variance decomposition of BSE and how Chinese and Singapore markets are over the period of time impacting the variability of BSE market, but the changes introduced in India only, I mean BSE only, then how this change is getting impacted over the period of time and how other markets are impacting Indian market to explain the variability in Indian market. So variance is decomposed for a change in particular country and its impact on variance of that particular country and due to other markets. So if you look at this, what you're finding in the first week, what we are finding that there is no impact of other market. So explaining the variability in BSE, because some changes in BSE, there's no impact in the first period itself of the Indian market. So Indian market, we can say, is not that much influential, at least from during those days where I've got the data, I mean 2011, and Singapore markets are unable to have any impact. But as we move to second week, what we are finding that there's very gradual decrease, not very strong impact of other markets even over the period of time. So if there is a change in Indian market, it percolates, I mean, it remains there. So change does not die out so soon, or impact of other in explaining the variability in the market is not reasonably done by the other market. If you compare the same data of Singapore, what you're finding for the period of time, the other markets are in Singapore, what you are finding that no market is significant here. Yeah, no, all are 99 here. This is 98, so India was also 98. So more or less all the three markets are behaving same way when it comes to bringing a change in a particular market and studying how that impact of a particular market is there in the market, in that market over the period of time due to itself and due to other markets. So impulse response talks about the impact on price, and variance decomposition talks about impact on variance. So both are there in a way to present to explain how other markets are impacting a particular market. That is the idea of impulse response and variance decomposition. One point to be noted, both are short-term in nature. Long-term discussion, if you have paid attention to what I have talked, the long-term discussion will be done. I think I talked somewhere about long-term discussion will be done by co-integration and error correction model, as we here I just had some discussion. So VAR is meant for short-term, and as we move to other chapter, we'll talk about the long-term talk. We'll start co-integration. I'm finding that people don't have any questions, so you're saving my time. Anyone has got any issue? So no one has any problem. Great. We are moving to. Okay, what do you mean when I say short term and long term? Any idea? Let's talk about short term and long term. What do you mean by short term impact of particular market? What is short term? How long it remains short term? When it becomes long run? Come on, question for you. Wake up.
Then maybe like after 5 years, till 5 years is short term. Like as you mentioned for beta that we take data till 5 years and then so maybe till 5 years it is short term.
Anyone else? Yeah, anyone else? Great. So I assume that topic VAR is over, and we are starting a new topic. I thought I'll have, let's start at least co-integration with the fresh. And the vector error correction model. So we are starting a new topic, co-integration and vector error correction model. So as I have discussed that if we have more than one variable, let's say argument say 3, and we would like to know the short term, then we can go for var. And when we talk about long term, so we are supposed to estimate vector error correction model, but there's a problem. This can be done only when there is a co-integration. So co-integration is the basis. Once co-integration says yes, there is some long-term association, then only we go for estimating the relationship in the form of vector error correction model. If there is no long-term association, then we have to manage with var. Point to be noted, if there is no long-term association, so we have to confine our discussion only with short-term because there is no long-term association. So what we are understanding, to find out long-term association, we need to talk about co-integration in time series. So there is no other way. We have got this y1 is equal to beta 0 plus beta 1. Let me use x1, x2. So if I have got this setup perfectly all right, but this setup, this setup is talking about multiple regression setup where they are clear-cut exogenous variables. But when we move from this setup and we assume that we have got all the variables which are endogenous in nature and we want to find out the long-term association, then we have to talk about co-integration. Here the point of interest is that this setup talks about relationship, but there is no demarcation whether it is short term or long term. No such discussion. This is just pure and simple relationship right now. But that does not serve the purpose, because as we go into depth, we would like to differentiate the relationship. So when we are having y is equal to x1 and x2, then I don't know whether it is short term or long term. That clarity is missing. So that's why I have to talk about a var and a co-integration. But this clarity of long-term, short-term discussion comes with a price. What is a price? Come on, what is the limitation of using var? Yeah. What is the limitation of using var? Under what condition I cannot use var?
Stationary.
Stationarity. What about other people? What is the stationarity condition? Come on, wake up. Yes. Anyone else? Not audible? Then you're not audible.
So you asked for a stationary, right? The condition
Yeah.
was stationary.
No, I asked for what are the limitations to VAR model.
Not sure, sir.
As we have discussed that the application of VAR is limited, that unless until the time series are I1, I can't use it. So typically the series should be stationary in level in first difference. If these time series are not stationary in first difference, I can't use it. So same condition applies on co-integration also. Co-integration cannot be applied when there is no this situation. Unless until this situation is there, I cannot, I should say, unless until this situation is there, I can't use co-integration also. So the conditions for using co-integration or VAR are same. Both can be applied only when you have got set of time series which are I1. They are not stationary at level, but they are stationary at first difference. So as I said that multiple regression does not provide you any such condition. It says that whatever variables you are using, they should be stationary. So convert them into stationarity and test the or run the multiple regression. If the time series is not stationary, convert that into stationary and run the multiple regression. But that type of facility you cannot have in case of VAR. In VAR, typical situation or co-integration typical situation is that time series should not be stationary at level, and it should definitely be stationary at first difference. If this condition holds true, then you can go for looking for application of VAR. So whether impulse response is a great tool, variance decomposition is a great tool, but you can't apply unless until it follows a condition of I10. Similarly, co-integration gives you very good idea about long-term association. Multiple regression does not talk about short-term or long-term. Co-integration will give you a very good idea about long-term association among the variables, or you can talk about the variable of your interest. If y1 is interest, then you have got y2, y3, y4, and you can study up to what extent long-term association is there between y1 and y2, y3, and y4. But if this condition does not hold true, this condition is not there, you cannot estimate it. I hope the point is clear. Limitation of using co-integration or VAR. So both are a few steps ahead of multiple regression. They give you a very good idea about short-term, long-term issues. Will disclose the co-integration, but limitation is VAR cannot be used as and when you want. So if I talk about long-term association, or the best example is there's a time series. Let's say this is y1, and you have let's say we are talking about y2, y1 and y2 only for the sake of simplicity. So what is happening if y1 and y2 are associated? So what will happen? That suppose this is time. So let me draw this diagram probably. So this is time, and here you have got y1t. So as time passes, let's say y1 moves like that, or y1t. So if y2 is associated, so y2 will also move same way. I mean, if it is associated, probably something like that. So here, point to be noted in the long run. See, say we are talking about long run. So what is happening that the y1 and y2 in short term, as you are finding that, if I'm, I could have used the other color. So if I'm having, let's say, so here point to be noted that the short-term movements are there. It's not that time series are always moving, ditto, same to same. No, it's not like that. They are changing. But important thing to be noted here is that the short-term changes are allowed, but in long run they are moving, or they are showing some sort of association. So that is the logic of talking about co-integration. So co-integration says that there is a long-term association. So short-term movements are allowed and adjustment takes place. And then if co-integration is there, then we try to study how fast. I repeat myself. When we find that there are times, let's say two time series, they have the co-integration. It means it has got the long-term association. Then we also try to understand how fast they manage with their short-term deviations. So the faster is the correction of short-term deviation, the better co-integration. It is supposed to be having the better co-integration. So we studied both the things. First thing we try to study whether there is a co-integration or not. If there is a co-integration, then we try to understand what is the level of co-integration, means how fast they can come back to their co-integration situation, because co-integration is for long term. So short-term deviations are allowed, but how fast they correct their short-term deviations. That's why we have got vector error correction model. It has got term known as error correction term, ECT. It's a very important term. So error correction terms will be defined as we run vector error correction model, and this term, the coefficient of this term, will tell us the story, how fast or how slow the short-term adjustment takes place to maintain the long-term association. But this discussion is meaningful only when there is a co-integration. As we have discussed, that the long-term association is there only when then we will be able to talk about the vector error correction model. If there is no co-integration, then no vector error correction model. If this is there, then only this is there. So vector error correction model, or the estimation of long-term association, will be only based upon whether there is a co-integration or not. So when we talk about time series, then co-integration is a very important discussion. If you randomly search, you will find that many research papers many studies are done to highlight the issues of co-integration, and you will find that many other discussions are attached to this co-integration discussions. And obviously the next obvious step when we talk about co-integration, it is vector error correction model. How soon, how fast the short-term correction takes place to maintain the long-term association. So that is what the co-integration is. Any question? We'll come back to the estimating the. So this is the same time series I can use because I'm studying more than one time series at a point of time. So what I'll do, I'll go for, again, I'll use 3, and to run the co-integration, I have to go for this. So co-integration are studied by one of the very famous methods. We call it Johnson's co-integration test. There are others also, but Johnson's co-integration test happens to be one of the most popular acceptable method of studying the co-integration. So that's why we are going to use it. You are there?
So
Yes, yes. Yeah, please go ahead. Here, I've selected this. I'll go for quick group group statistics and Johnson's co-integration test. If I click this, I've got this dialog box. All the 3 selected are there already by default. If they are not there, I would have entered. Like I go for OK. And here, one point to be noted: before we run co-integration, we would have obviously run the var. I'll again highlight what I'm saying. I'm interested in studying the co-integration, but co-integration is also dependent upon the appropriate number of lag terms. An appropriate number of lag terms in co-integration comes from var. So that's why we will be again doing this formality, open as var, and we'll open this. We'll go for appropriate lag criteria thing. We'll go for 10. I've taken more as we have discussed, and what we are finding 9. So appropriate lag length in a var setup is 9. So when we run the co-integration, we'll continue with that appropriate lag length. That is 9. So quick group statistics, Johnson's co-integration test. Okay, here I'll go for 9. So this 9 is not coming from anywhere else but coming from var. All the setup will be taken care of as it is. No further change. And look here. we are having two criteria to decide whatever is the appropriate co-integration. First of all, there is a co-integration or not. One thing is known as trace statistics, trace. Another is max eigenstatistics. So these are the statistics, and we have got multiple hypotheses. So this is none what you are finding here in both the cases. Let's concentrate on trace only. This is H naught. And then it is saying no, at most one, at most two. And it is very handy when you run Johnson's co-integration test on eViews. It is showing you asterisk. It means if I write it down this way, so that it becomes more meaningful. So it is, pair of, it's not pair anymore. H naught says co-integration 0, no co-integration. R1 says R is equal to 1. H2 say R is equal to 2. So if this is rejected, so it is accepted, obviously. If this is also rejected, so this is accepted. So this goes in this sequence only. And we look for the maximum. So maximum is the thing which we look forward to. So when we say this is rejected, this is accepted, so we'll say that there are two co-integrating equations. We'll understand that when we move to vector correction model, next step, obviously. So right now what we are trying to understand, just because right now we have taken three, y1, y2, y3. So co-integrating equations are how many linear associations are there? So y1 can be with y2, y1 can be with y3, y2 can be with y3, and then y1, y2, y3 all can be together. So these are possibilities. So out of possibilities, we have to figure out that how many possibilities are true. That is what this test is, and this sequence of hypothesis. So we look for maximum, which is rejected. And obviously next number of the hypothesis will be accepted. And that will be the exact number of co-integrating equation. So the results are very self-explanatory. If you look at trace only, this is rejected, means null is rejected. Then first alternate is also rejected. It means this is rejected. So it says that this is rejected. So R is equal to 1 is rejected. So next is going to be accepted. So R is equal to 2, number of co-integrating equation is 2. So if you read here, trace test indicates two co-integrating equations. Similarly, here also you are finding two, but at times both are giving you different results. Then being conservative, you can pick the lesser number of co-integrating equations. Choice is always yours, how you would like to be interpret the results. But results are this, both may give you same as in our case, but they can give you different results also. You can go for conservative view, you can go for liberal view, that depends, choice is yours. There's no clear-cut rule as such on that. You guys are with me? So right now, when I have studied the three, BSc, China and Singapore, what we are finding that there are two co-integrating equations. Just because both are giving same results, so I'll also conclude that there are two co-integrating equations. Anyone has got any question? So we'll close today. I'll share with you when we are going to have the next quiz and all. And this war is over. And co-integration most probably will be, I have to just talk about vector error correction part, and then I'll start, if you remember, I've discussed this regression is over. We talked about ARIMA is over. We have talked about VAR is over. All these what we have studied, and we are right now talking about co-integration and vector error correction model. This will also be our next class. And then we have two topics left. We'll have panel data, and we have got volatility models. So next class we'll start this, and I have got 5 classes left. So roughly my planning is that 2 or 3 here and 2 or 3 here, and obviously I have to have, this is the plan for the remaining sessions. And most probably next class I may have on Friday. So let's see whether I'll have a class on Friday or next week. That depends. So I close it. Thank you.
Thank you, sir.